nuclear decay or nuclear reaction. Before we start, we know that till this point you have learned only chemical reaction, not nuclear reaction. That means you know that an atom contains protons, positive protons and neutral neutrons in nucleus, and there will be energy levels where electrons are revolving, right? So in chemical reaction we know that these electrons are either losing or gaining or sharing. So only change is happening only to what? The valence shell of an atom. Okay. So in a chemical reaction there is actually rearrangement of electrons takes place. Rearrangement means they may gain electron, may lose electron, or what? Share electrons. Okay. So after that we know that their stability is changing, right? So electron arrangement is changing. They may be coming closer to the nucleus or maybe going away from the nucleus, and they will form something called what? Bonds. Maybe an ionic bond if they are losing or gaining ionic bond, or if they are sharing, what is a bond? It is called covalent bond. Okay, so those are the two types of bonds forming. What stays the same? We know that if chlorine react, it will still be the chlorine, right? Maybe it changes into ions or some other compound, but the element symbol will be same. So we can say the identity of the element is not changing. Then amount of energy, we have learned exo and endo while reacting, they are bond breaking, bond forming, but we have seen that amount of energy releasing it's very less, like say for example combustion of methane sometimes release 90 kilojoules of mole. So that is a small amount of energy if you compare to that to nuclear reaction. So a nuclear reaction involve in the change of the nucleus of an atom. Okay, change the nucleus of an atom. That means we know that nucleus contains protons and neutrons. Protons are carrying the identity of an atom. That means the element is changing into something else. So there will be protons number changing or neutrons number changing. Also you will see there will be electrons number also changing, even though there is no electrons in the nucleus. Okay, so you don't need to write that because we will see, I'll explain that time. Okay, what can happen? The identity of the element is changing. Identity of the element is changing, and energy scale will be huge amount. We know that what are the impacts of nuclear reactions, right? It can burn a whole country, right? We have seen that earlier during Second World War time. Okay, so radiation, we are all familiar with that word, radiation. So radiation is a specific name for energy, or we can say it is a type of subatomic particle emitter, or it is a type of subatomic particle. Okay, you will see that more detailedly in a minute. Okay, so We are going to mainly discuss about three different type of radiation. There are so many type of radiation, but we are going to learn first one. It's emission of alpha. So we're using Greek letters. This is how you write alpha. If just write like A, then like this. Okay, alpha, beta. Beta is also like write a B, and I'll add tail into that. Okay, and gamma, like this. Okay, these are the main type of radiation you are going to see. Alpha radiation will be a positive radiation. We will talk about that later. Okay, there is a table for that. Okay, so what is radioactivity is? Radioactivity is a spontaneous emission of energy from where? From the nucleus of an atom. Why it is emitting radiation is because it needs to, in order to attain stability. So always, if they have higher energy, they are less stable, so they need to go to a low energy state. Okay, so we have seen there are so many applications, and at the end of the unit we will discuss all the applications, and we will read the resolution paper also. Okay.